morning and welcome. Welcome our subject energy engineering for engineering students as well as SaaS course. So this is lecture number 12. So around prior to that, we'll just have revision of the last three. And we have seen in my diagram, ESPs is seen here and ash and ash storage. And this will have seen the electrostatic pressure paper. Ash condensing, ash storage pressure. This comes under ash condensing. What is the ash condensing system? So a lot of ash is being generated in the power plants, and it is essential to remove daily lots of tons of that coal generated, and is to meet the way so as to take care of environmental effects. Accordingly, these are the systems of ash and pneumatic system, electrostatic precipitation system, and mechanical dust collectors. So I will just pass through low pressure system. These are the troughs, water troughs. After combustion, the burnt ash, you can say, or gas fall down on the trough, water trough from the furnace, and is being collected with the help of high velocity of water jet to the ash sump. So there may be 2, 4, 6 water troughs accordingly used in the low pressure system. So here it is in low pressure system, means water pressure is comparatively lower than in high pressure system. Okay, in high pressure system there are hijectors or used or nozzles are used. See, you're seeing in the figure 3 nozzles or 3 high pressure water taps, you can see. So after combustion, the ash falling on the stoker is being collected to the hopper, bottom hopper, while flowing down. The high pressure water jet at the top extinguishes the or reduces the temperature of this ash. Then while flowing down, this ash mixing with water is sent to some through the water troughs. Okay, then we saw pneumatic systems. Pneumatic, instead of water, this ash which is being collected at the bottom hopper is crushed in the crusher or grinder, and with the help of hijectors and with the air velocity, the ash is being sent to separators, where ash gets separated and the air goes to the along with flue gas, you can say, goes to the exhauster fan, to the chimney, to the atmosphere, and the ash is being collected in the ash hopper, then it is discharged to the sump. Okay, so this one most important, electrostatics precipitator, which consists of electric field in the electrostatic precipitator, causing ionization of the ash while flowing from, you can say, economizer, air heater, and then coming into the electrostatic precipitator. This flue gases separates into positive and negative ions, ash, with the help of this corona effect we called, and then they are being collected into the bottom hoppers. Number of hoppers we had in 210 megawatt, around 40 hoppers were there. So you can see how much large area is required, is acquired by these electrostatic precipitors, and through these 40 hoppers in every ship, these 40 hoppers are evacuated with the help of water jet or water hijectors. Okay, so This is most efficient. And I told 90 to 99% of the ash is being removed in the ESP. The efficiency is very nice. Advantages are effective, easy to operation, draft is less, loss is less, most effective for high dust loaded gas. Maintenance cost is less. It's true, but at the same time, disadvantages: space requirement is more, necessary to protect the collector property, high running cost, and high capital cost. Then we saw the mechanical system: boiler furnace, ash collected into the hoppers, falling onto the trough, water trough, and being conveyed by the belt conveyor to the bunkers, ash bunkers, where from you can directly load to the truck, which can be sent out for useful work. Nowadays, these ash are being widely used and for this bricks purpose and very useful. Initially, it was not much known. Now, this ash is being widely used in the preparation of bricks. Okay, so today we'll start with this for last lecture of introduction to thermal power plants. Lecture number, sorry, maybe 11. We'll see correct it later on. Then boilers last. As before brushing again, we have seen this Rankin cycle, and this is the basic thermal power plant cycle: boiler, turbine, condenser, pump, and boilers. We have seen this 1 to 2, 3 to 4, 4, 5, 6, 7, 8. So reheat again, then regeneration by means of extracting steam from turbine to the HP heaters. You are seeing this 1 and 2, and LP heaters 1, 2, 3, 4. You can see. So what is the purpose? You can see that the heat is being added to the water before sending it to the boiler for generation of steam. So due to this regeneration, less amount of fuel will be required to convert water into steam. You can see from this graph. So this much space is required. We can say this is latent heat of evaporation is required. Latent heat is required for combustion purpose. If you go down, these are the various pressure lines on this Carnot cycle, Rankine cycle. So lower the pressure, higher the latent heat required for conversion of water into steam. As you go on increasing the pressure upward direction, you have studied already. So the lesser the latent heat required. If at a certain point, you can say that critical point, okay, around 220 bar, 221 bar, and around 374 degrees Celsius, the temperature, the liquid directly flashes into steam without latent heat. That is new technique coming in boilers, so that higher the pressure is being used. We call it critical pressure boilers or supercritical boilers. We term them as high pressure boilers. We are going to see in the following topics. That's why I just briefly explained how this Rankine cycle. Okay, so these are the parameters: 150 kg per centimeter, 320 degrees centigrade before going to the through the economizer to the furnace. Then these are the parameters of our 210 megawatt plant. These are the HP heaters. There are 3 HP heaters and 4 LP heaters through which the generation of heat is taking place. And this is the reheat here only shown 3. Sorry, yes. First expansion in HP turbine, second expansion in IP turbine, third expansion in LP turbine to extract more and more heat energy to mechanical to electrical energy. Okay, so classification of boilers first we'll see. Again, in brief, water tube boilers according to the flow of water and hot gases: water tube, fire tube. If water is through the tubes, it is water tube boilers. If fire is through the tube, it is fire tube boilers. Axis of boiler: vertical, horizontal, inclined. According to position of operation: internally fired, externally fired. According to the method of firing, we have seen in last classes: overfeed, underfeed. According to application: stationary, mobile, Mobile means marine and locomotives in earlier steam engines. You can say trains. This mobile boilers we are called as, according to the circulating water, natural circulation, forced circulation, according to the steam pressure, low pressure, medium pressure, high pressure, and according to the draft, natural draft, forced draft, induced draft, balanced draft. You have already studied, that's why I'm not showing. I'm little going fast. Okay. Next slide. Then we are going to deal with high pressure boilers in this particular lessons, or you can say the topic. Slide. High pressure boiler. Why high pressure is needed? I just told you use higher and higher pressure so that latent heat is reduced and less fuel is required to convert water into steam. So that is the main concept of this high pressure boilers. The efficiency and the capacity of the plant can be increased as reduced quantity of steam is required for the same power generation. If high pressure steam is used, means steam also requirement is less if you use high pressure steam. The forced circulation of water through the boiler tubes provides freedom in the arrangement of furnace. So furnace can be compact. If the pressure is more, furnaces are more and more compact, and water walls, in addition to the reduction in the heat exchange area. But absolutely. The tendency of scale formation is reduced due to high velocity of water. The danger of overheating is neglected or reduced as all the parts are uniformly heated, and the differential expansion is reduced due to the uniform temperature, and thus reduces possibility of gas and air leakages. So this high pressure boilers reducing the leakages, also chances of leakages, uniform heating. Then forced water circulation is again uniform circulation. Efficiency also increases, less fuel is required and less steam is required for higher capacity of generation. So first we'll see, we are going to deal with the two boilers, high pressure boilers. One is Lamont boiler. It is forced circulation, means what pump is there, water tube boiler, which was first introduced in 1925 by Lamont, hence the name given. The feed water from hot water is supplied, hot well is supplied to a storage and separating drum or boiler through the economizer. Most of the sensibility is supplied to the feed water passing through the economizer. To secure uniform flow of feed water, each of the parallel boiler circuits, a choke is fitted at entrance to each circuit. These boilers have been built to generate 45 to 50 tons of superheated steam at a pressure of 125 bar. Just note it, and temperature of 500 degrees centigrade. Okay, important components of this Lamont boiler. You have to draw this figure. You can just see the figure. In this figure, you are seeing at the upper side cold air in. This is the aerated zone blower with the help of cold air going in, and then hot air coming out of this aerator and is being used in the combustion chamber for heating the fuel. Then you will see the this forced circulation pump, feed pump, you can say. This is feed pump. From feed pump means from turbine side, it is the water is first taken into the economizer zone, then water drum. From the drum, there is a one pump that is called as a circulating pump, forced circulating pump. Then this is goes through the distributed header. Then it passes through the radiant. First zone is radiant evaporator. Then it passes through convective evaporators. From them, it again passes through drum. It again goes inside the boiler for superheating, and that superheated steam is being utilized for generation of electrical energy, you can say electricity. So these are the components: economizer, superheater, convective evaporator, and radiant evaporator. Pump, drum, feed pump is turbine side, and aerator. So while the flue gas is flowing in the upward direction, they give heat from you can say convective, superheater, economizer, aerator, and then goes to the atmosphere through ID fan and chimney. Okay, so this is about this. The components just I told. Drum is there, separate, which separates water and steam here. Circulating pump here. Distribution header is shown here. Radiant evaporator. The most one thing is to be noted here: the hot flue gases do not pass. So the hot flue gases just passes from convective evaporator and then goes, and the whatever the heat radiant evaporator is getting by means of radiation, and the water gets heated in the radiator zone. That is the important. Then this is a convective evaporator where it gets heat from the flue gases, and water is getting converted into steam. And in suppurator, it is converted into suppurated steam into prime mover turbine. Economizer, the waste hot flue gases flows through the economizer and air freighter. So that water is being preheated before sending it to the furnace or drum to furnace, so that less fuel is required, and air is being preheated to the before sending it to the combustion chamber in the aerator. So this is about Lamont boiler. Advantage and disadvantages. Lamont boiler can generate 45 to 50 tons of separated steam at a pressure of 120 bar and temperature 500 degrees centigrade. Drum is of small size. Tendency of scale formation is eliminated. Scale formation inside the tube is due to forced circulation of water. Disadvantages: bubbles are formed. See here on the inside of the water tubes due to the radiation, or you can say convection, while flowing from the water bubbles from outer surface to inner surface. The bubbles, more bubbles are chances of over, heating may not be proper, and bubbles remain inside the tubes, and which reduce the heat transfer rate. Initial and operating costs are high. Maintenance costs are also high. Now let's see the second one, Benson boiler, which is called as a supercritical, means the pressure is about 221 bar. It is around 225 bar. Somewhere it is written here, critical. The main difficulty experienced in Lamont boiler was formation of bubbles on the inner surfaces of the heating tubes. The attached bubble reduce the heat flow and steam generation, as it offers higher thermal resistance compared to water film. So these bubbles do not pass the heat to adjacent water particles. So you can say resist the heat flow. That is removed in these Benson boilers. Scientist West Germany who found this in 1922 argued that if the boiler pressure was raised to critical pressure 225 atmosphere, the steam and water could have the same density, and therefore the danger of bubble formation can be completely removed. The components are same again, just a little difference. The suppurator is in between convective evaporator and radiant evaporator. In earlier case, the suppurator was above the this, you can say, convective evaporator was in between suppurator and radiant evaporator. The second difference is that the hot flue gases flows from bottom, radiant superheater, convective suppurator, economizer, aerator, and then goes to the atmosphere through the ID fan. Okay, all other functions are same. Second difference between Lamont and Benson boiler is there is no circulating water pump in the Benson boiler. No circulating water pump, and this radiant flue gases flows over the radiant heat tubes, radiant heater area. So that are the main difference, but functions are same. Okay, we'll see the disadvantages and advantages. As there is no drum, one more point to be noted: drum is not also there, pump is also not there. Okay, that is also one more difference. As there is no drum, total weight of Benson boiler is 20% reduced, less than other boiler. This reduces the cost of the boiler. Floor space requirement is also again less. Transportation of boilers parts and its erection is very easy as other compared to other boilers. Natural circulation boilers require expansion joints in pipes, but the pipes in Benson are welded. So that one is an advantage. As the Benson boilers operate at high pressure and temperature, special alloy materials are required. That's why automatically the overall cost of the plant increases. Maintenance costs are also very high. Overheating of the tubes takes place due to the high pressure and temperature. That's about the Boilers. Last point is in this is FBC, that is fluidized bed combustion, burning of now we have seen all the Benson boilers, Lamont and other high pressure boilers. Pulverized fuel was used, coal, and so combustion efficiency to improve the efficiency. But this burning of coal has some limitations, some problems such as particle size of coal used in pulverized fuel is limited to 70 to 100 microns. The pulverized fuel furnace is designed to burn. Now this is design, special design has to be done for this pulverized fuel and cannot be used. When it is burned for only pulverized fuel, you cannot be used for other type of coals with same efficiency. The generation of high temperature means there is also inside that furnace the temperature goes above 1000 degrees centigrade, that is up to 1650 degrees centigrade in the furnace, creates number of problems like slag formation on superheater. Slag formation always takes, soot formation also takes place, evaporation of alkali metals in ash and its deposition on heat transfer surfaces, formation of SO2, which is a danger, formation of SO2 and NOx in large amount. This is fact. Fluid. So, in order to overcome all this difficulty, a new concept, a new, you can say, invention has been taken and done in this area, and fluidized bed combustion system, that means coal plus water or coal plus liquid is being used as a fuel. Coal slurry is called it as, can burn any fuel including low grade coals. Here most important, even containing 17% of ash, oil, gas or municipal waste. Improved desulfurization and low NOx emissions are its main characteristics. The fuel and in internal dolomite, inner dolomites are fed on a distribution plate. So you can see this boiler furnace. So this is the fuel and dolomite is being sent to the grate, and here water is being supplied from the bottom. There are a number of water tubes, and water is in the tubes around in this shell, and after getting heat it is converted into steam. So this is the fluidized bed. Fuel is there, fuel plus placed on this distributor plate, you can say, and then when air is being forced from the bottom and heated, the combustion is being taking place. We'll see here the fuel and the internal dolomite are fed on a distributor plate, and air is supplied from the bottom of the distributor. The air is supplied at high velocity, so that solid fuel material remains in suspension condition during burning. The heat produced is used to heat water flowing through the tube and convert water into steam. During burning, SO2 form is absorbed by the dolomite. So this dolomite, what it does, whatever the in the is formed, absorbed by the dolomite, and thus prevents its escape with the exhaust gases. So SO2 formation is reduced to about 15%. Here it is written, and also the temperature in the furnace, it is maintained in 800 to 900 degrees centigrade, which also makes NOx component reduce. The major portion of the coal available in India is low quality, high ash content, and low calorific value. The traditional grade fuel firing systems have got limitations and techno-economically unviable to meet the future. So fluidized bed combustion has enlarged as a viable alternative and has significant advantages for conventional firing system and offer multiple benefits, that is compact boiler design, fuel flexibility, higher combustion efficiency, and reduced emissions of NOx and SOx. Okay, this is in brief about FBC. FBC system can be used any type of low grade fuel, including municipal waste, and therefore NOx formed during burning. Okay, around 15% of the sulfur content, SO2 component is reduced. There is saving about 10% of operating cost and 15% in the capital cost of the power plant. The size of the coal has pronounced effect on the operation and performance of FBC system. This is one more important. The particle size is 6 to 13 mm, sometimes 50 mm size can be also used in the system. Here you are seeing 50 mm, whereas in pulverized fuel system, you have to use 200 mesh size. So these are the major advantages of this fluidized bed combustion, which is a new technology nowadays being utilized. Okay. So with this, the boilers, high pressure boilers, fluidized bed combustion part is over. And the first, you can say, unit 1, part B is almost completed. Now in next topics, we'll study part A. Till then, bye. Bye. Thank you very much.